Find the dimensions of the rectangular box of the largest volume if the total surface area is 64 cubic meters or centimeters. Okay, let's draw a picture. So basically I'm looking at something that looks, kind of like this. And if I think of this as x, y, and z, we want to maximize the volume. And the volume is just going to be x times y times z. But we said the surface area is 64 square centimeters. I think I said cubic earlier. If I did, sorry. It's square centimeters. So the area of this box is going to be equal to, let's see, x times z will give me this surface area times 2. So this will be 2, well, it's going to be 2 times everything. So 2xz plus xy plus yz. That's going to be the surface area. But we had a restriction, and the restriction was that this can be no more than 64. So 2 times xz plus yz, xy plus yz is 64, which of course I can say xz plus xy plus yz is 32. So what I need to do is I need to maximize the volume x of x, y, and z. There we go. But I really want to do this as a function of x and y. So based on this, I can solve this for z. And what I get is, let me see, I have xz plus yz equals 32 minus xy. So z is going to be 32 minus xy over x plus y. I can substitute that in right there. And that tells me that my volume of a function of x and y is going to be x times y times 32 minus xy over x plus y. So now I'm going to do what you're expecting me to do. I'm going to start working on some partials. So the partial with respect to x. Now this is going to take a little bit of time, but let's go ahead and just go through it carefully here. So this is going to be y times 32 minus xy over x plus y plus xy times, I need the derivative of this. So this is going to be a negative y times x plus y minus 32 minus xy times the derivative of this with respect to x, which is just 1, over x plus y squared. So I'm going to end up with, see, I'm going to add these, so I'm going to take y, let's just factor out both these y's right now. So we have y times 32 minus xy times x plus y over x plus y squared plus, and seeing I have the same denominator, let's just go put them all together right now, plus x times what I'm going to have up here. I'm going to have a negative xy minus y squared minus 32 plus xy. And of course this all has the same denominator now. So let me see here, my xy's are going to go away, which I'm going to end up with, let's see what's left. I got y times, let's go distribute this, 32x plus 32y minus x squared y minus xy squared. And then this is going to be minus xy squared minus 32x all over x plus y squared. See, I really want to simplify this because I'm going to have to take this derivative again. So I'm thinking the more I simplify it, the nicer life is going to be. So these 32's will go away, which brings me to, see, each of these guys has a y, so I'm going to factor out another y. So I have y squared times, what's left here? 32 minus x squared minus xy minus, well, I should have combined these. So minus 2xy over x plus y squared. Okay, I think that's probably going to be a little bit easier to work with. So to make it easier to find a little bit later, I'm going to put a box around it. This is my partial with respect to x. Now, let's go ahead and find the partial with respect to y. So let's see what I'm going to have. I'm going to have x times 32 minus xy over x plus y plus xy times, see, negative x plus y minus, 32 minus xy over x plus y squared. So let's see, very similar to what I did last time. Let's factor out an x and work with, I need to add these together, so this is be 32 minus xy times x plus y plus I'm going to have x times, just work this out, this is a negative x squared minus xy minus 32 plus xy, and of course this is all over x plus y squared. These are going to go away, and let's go ahead and, well, no, not yet. See, this is going to be x times, distribute this or expand this, however. See, 32x plus 32y minus x squared y minus xy squared. This is minus x cubed minus 32x all over x plus y squared. So let's see what I have here. I've got negative 32x and positive 32x. Those will go away. And oh, I just noticed you probably freaked out when I did this. I factored out an x and I left an x. This is supposed to be a y right here. Yep, need to make a correction. If this is a y, then when I multiply through, what do I end up with down here? Where is that? Here. So this is not a negative x cubed. This is a negative x squared y minus 32y. So this 32x did not cancel. I need to put that 32x back. So now if I start canceling, it's the 32y that goes away. And let me see. Now everything left here has an x in it. So if I factor out an x, I'm going to have, see, x squared times 32 minus xy. Actually, there's two of them. minus y squared all over x plus y squared. So let's take a quick look and make sure we got everything. Okay, yeah, this looks good. So now what I want to do is I need to set the partial with respect equal to 0, with respect to x equal to 0. So what I have is I need this is equal to y squared times, it was 32 minus x squared minus 2xy over x plus y squared. When I set that equal to 0, remember y is a constant with respect to x. So really it's going to be 0 when this equals 0. And then I'm going to end up with, see, 32 minus x squared minus 2xy equals 0. And then that suggests, I think I'm going to solve this for y and substitute that into the partial with respect to y. So that would then suggest that what do I have? Y is going to be equal to negative 32 plus x squared divided by a negative 2x, which I think I'll go ahead and write as, let's see, simply 32 minus x squared over 2x by factoring out the negative and canceling it. So now what I want to do is I want to substitute this into the partial with respect to y. Whoops, y. And when I do, see, I'm going to have, see, x squared times 32 minus 2x, and here's a y, which is going to be 32 minus x squared over 2x minus, I'm going to have another y here, squared, 32 minus x squared over 2x squared. All of this over x plus y squared, so this is x plus 32 minus x squared over 2x, and this whole thing is going to be squared. And I need to set this equal to 0. So see, that would give me that I need 32 minus, well, if I distribute this here, I'm going to have 32 minus 32 plus x squared minus, let's see, I'm going to have 32 squared minus 64x squared plus x to the fourth over 4x squared. That's got to be 0. Well, these 32's go away. And see, what does that give me? If I multiply through by 4x squared, I end up with, see, 4x to the fourth minus 32 squared plus 64x squared minus x to the fourth is 0, which means I need to solve 3x to the fourth plus 64x squared minus 32 squared equals 0. This is quadratic in x squared. And when you solve this, you use a quadratic formula or whatever you want to do. What you're going to end up with is you're going to see that you have plus and minus 4 root 3 over 3, but obviously the negative root doesn't do you any good because we're talking about dimensions here, so they're lengths or distances. So only the positive root has meaning, and you're going to find that the solution is 4 root 3 over 3. Now, recall that y was equal to, by the way, that's x. Y was equal to 32 minus x squared over 2x. That means when I substitute this in for x, that will give me 4 root 6 over 3. So this is my critical point. So my critical point, you have coordinates 4 root 3 over 3 and 4 root 6 over 3. Now recall that we said z was equal to 32 minus xy over x plus y. So just substitute these values in and you're going to get the actual coordinates, or that's a coordinate, well, it is coordinates, but it's going to give you the dimensions, the x, y, z dimensions. Now, I'm not going to do a second derivative test of this because I'm going to fall back on the fact that based on the physical nature of this problem, the minimum is trivial. Because remember, the volume was equal to x, y, z. The minimum is going to be when either x or y or z is 0, which gives you a volume of 0. So clearly, this is going to maximize my volume, these coordinates. And you can just plug that in and grab a calculator and actually finish that up to get the actual dimensions.